All right, powers of monomials. Basically, we are taking a power of a monomial, which includes a number, a variable, or even a product of a number and variable together. The first type is a power of a power, meaning we have something raised to an exponent and then it's raised to another exponent, just like in this example right here. So what we see here, we have 2 to the 5th power, and that whole thing is being raised to the 2nd power. So what we do is we keep the base of 2, and then we raise or we multiply the exponents. So 5 times 2. So this time we're going to end up with 2 to the 10th power. And this is the simplified version. If they wanted you to evaluate it, then we have to multiply 2 times 2 times 2 10 times. But right now, we're just going to leave it in the simplified form. This rule, like in part B of multiplying the powers or the exponents, can be extended out forever or however long they want to do. So in this case, we have a base 3 being raised to the 2nd power, that being raised to the 3rd power, and then that again being raised to the 4th power. So all that means is we're going to keep our base of 3, and we're going to multiply each of these 3 powers. So 2 times 3 times 4. So that's going to give us a base of 3. And then 2 times 3 is 6. So we go 6 times 4. And then 6 times 4, which is 24. So again, I'm just going to leave it in the simplified form because I'm not going to multiply that all out. But that's what that looks like. And that's a power of a power. Okay, so in this third example, it's a little different. This time we have a product right here inside, meaning we're multiplying this monomial right here, but we're raising this whole product to a power. So this is a power of a product. So just like we did earlier, we want to raise both of these to this 2nd power. So in essence, what we're going to have is we're going to have this 7. And since 7 doesn't have an exponent, it is 1 times 2. And then the c, it has a exponent of 8. And so that's the 8 times 2. So we're going to end up with 7 to the 2nd power and c to the 16th power. Now we can simplify that more, which usually we do in this case if we have variables and numbers combined. So I'm going to simplify that more. 7 to the 2nd power is 49. So we end up with 49c to the 16th power. And make sure that the 16 stays with the c, not the 49, because originally the exponent was with the c in the original problem. Okay, in our next example right here, we have -3, x to the 4th, y to the 7th, and all of that is raised to the 3rd power. So again, we have a product being raised to the power of 3. So that means each individual factor needs to be raised to this 3rd power. So once again, we're going to have this -3. It has a 1 times 3, since it didn't have an exponent, times x 4, and the exponent is 4 times 3, and then the y had an exponent 7, so we're going to multiply that by 3. So we're going to end up with -3 to the 3rd power times x to the 12th power times y to the 21st power. And again, we can simplify the number part. -3 to the 3rd power is -3 times -3 times -3, which gives us -27 x to the 12th, y to the 21st power. So this is our answer at the end.